Okay, I'm going to try this problem again. I recorded this once already, but for some reason sound was not on there. So let's try this again. The type of problem we have is we're given information about two cables and the amount of force on each cable that is holding a box or some object. And in this case, we're given the forces in the cables, and based on the angles at which those cables lie, we should be able to calculate how much the box itself weighs. So if we look at this in a vector format, I guess it says 42 pounds makes a 64-degree angle. So that means this here is 64. The other rope is 27 pounds and makes 26 degrees. So this is our 26 degrees. What we need to know about, I guess this is more like the applied math side of it, is what you need to know is that when you work with a problem like this, in order to find the mass of the object, what we really want to find is we have the magnitude of the vector. We'll call this vector A, and this vector B. The magnitude of vector A in total is 27 pounds, and the magnitude of vector B is 42. But what we can do with that, based on this 26 degrees, 64 degrees, is we can break that 27 pound magnitude into its x and y components, just like we can break any vector into its I hat and j hat components. So that's kind of like what we're doing here. It's like taking a problem where it says, given the magnitude and direction angle, find the component form of our vector. So let's do that. Let's find the component form of A and B. So to do that, we are going to first work with B. So vector B in component form is, remember, it's magnitude of B times cosine of theta, and that's our I hat, plus magnitude B times sine theta, and that's our j hat component. So in this case, our magnitude is the amount of force, or 42 pounds, and cosine theta. Now theta in this case, remember with vectors, theta is always from the 0, the positive x-axis, up to our vector. So in this case, that's exactly our 64 degrees. And then 42 sine of 64. And that's our j hat. So we've just taken, and the amount of force total in B is 42 pounds. But the amount of force in the x direction is 42 times cosine of 64. And the amount of the 42 pound force that is applied directly vertically is the 42 sine 64. So let's go to vector A and break it up. The first thing we got to do with this here, I'm going to highlight this. Let's do all of A in blue. Okay, we'll highlight that, change that to blue. Remember, our vector direction angle has to go from 0, like the positive x-axis, around to our terminal side, our vector. So how do we find theta? Well, if we call this alpha, 26 degrees, then theta is like going all the way 180 degrees minus alpha. So just real quick over here, this is theta A. That's just so we have this all labeled, theta B. So theta of A is actually 180 minus alpha, or 180 minus 26, which is 154. Alright, so back to breaking up our vector into its x and y components, or I hat, j hat components. We will have magnitude, which in this case is 27, times cosine of 154. And again, that's I hat. Fix that one. And 27 sine 154. And that's our j hat. So again, if we want to know how much mass this object, this block has, all we're really looking for, all that we care about, is how much force is being applied from 42 and 27 just in the y direction. Well, the y direction is our j hat, right? It's our sine component. So of this vector, we really don't care anymore about the I hat components. What we really need is the j hat components. So we're going to take, I'll go down here. We're going to take 42 sine of 64 degrees plus 27 sine of 154 degrees, and that should give us all the total amount of force in the y direction, and it's the y direction because gravity pulls us straight down. So if we take and run that in our calculator, that gives us 37.75 plus 11.84, which is about 49.59 pounds. So that is given a box with two cables, and you know the forces on the cables. You just need to find the mass. What you're really being asked for is find the total amount of y force in each vector. And in order to do that, you're taking magnitude times sine of theta, where theta starts at 0 and works its way around. You add those two together, and in this problem, you get 49 pounds. The other type of problem you'll see, it'll actually be the take-home problem, but anyways, you're going to be given the amount of mass here. It's like 800 grams or something. Nonetheless, you'll be given the mass, and you'll still be given these angles that the cables are at. But what you'll have to do is find the amount of force in each cable. What you end up with then is two unknowns, right? The amount of force here is an unknown, the amount of force here is an unknown, and they're two different forces. So it's a very different approach, but the one on the test, again, is just like this, where you just add up the j hat components.